Now, there's a little more to it than just that. Because if you notice, it's not an exact replica, is it? Notice the beginning is C8, where this is CA. C8 and CA. What do they do there? Well, they want to make sure this is unique enough. They want to make it unique enough. So what they do is they flip the 7th bit from the left. That's right, they flip the 7th bit from the left. Well, how do they do that? Well, what are we dealing with here? We're dealing with CA. Well, let me show you how they convert CA into C8. We're going to go ahead and do that right now. Let's give ourselves some white space to work with. So we said we had CA. We're going to go ahead and put CA right here. Now, those are hexadecimal values. Hexadecimal values have 4 bits each. So we can convert this into binary, which is going to help us out here. So what is C in binary? Well, we have to convert it to decimal first. It's going to make it easier on ourselves. That's right. Hexadecimal to decimal to binary. So C is what? Well, if you're not sure, remember what our hexadecimal characters are. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have A, which is 10, B, which is 11, C, which is 12. So that's 12. C is 12. So how does 12 look in binary? Well, 12 in binary is going to have this value set. It's then going to have this value set. It's not going to have this value set or this value set. So what are these binary values? Well, if we work from right to left, this is the 1 spot, the 2 spot, the 4 spot, the 8 spot. So we have 8 plus 4 equaling 12. It's as simple as that. So that's our C. Now, what is our A? Our A, well, we said was 10. A is 10. So what does 10 look like? Well, 10 is going to have 8 set. It's not going to have 4 set because that would be too much. 12. And then it has 2 set because 8 plus 2 is 10. And then the 1 is not set. So CA in binary looks like this. 1, 1, 0, 0, 1, 0, 1, 0. That's what we have. So now we said we flip the 7th bit from the left. 7th bit from the left. So there's bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. Bit 7 is a 1. Bit 7 is a 1. So flip it. So that's a 0 now. So that stays a 0, that stays a 0, that's a 1, that's a 0, that's a 0, that's a 1, that's a 1. There we go. So now this we have to convert back to hex. So break it into groups of 4. Break it into groups of 4. So I'm going to draw a line right here for you. So if we drew a line up here, it would look like this. There we go. That's what I want. That's what it looks like. So now, when we convert it back, well, this is, what is that? That's 8 plus 4 is 12. So that's still C. That hasn't changed, has it? No, but now we have 8 plus 0 plus 0 plus 0. So that's 8. So that's just 8. So C8. There you go. C8. That's how they derive the C8 from that address. So let's take a look at that again. We're going to go back to our output. And our output says that our MAC address is CA02, but once we do the bit flipping, we have what? We have C802, followed by the B. So 0B. Why is the 0 not there? Because remember, you can drop leading zeros. So they drop leading zeros in that field. So that's why the 0 is not there, but the B is there. And then you have F, 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 E, fill the field with fluff every time. Then you have your 6, 4. And then you have your 0. Why 0? Because you can remove all the leading zeros there and get your 0. All right. So that is how we can have our global addresses auto-generate their interface IDs using EUI 64, which just pulls from the MAC address, fills the field with fluff every time, flips the 7th bit from the left. But I want to show you now what happens when we already have a link local address on an interface. So I have this link local address on the interface. I've already said, hey, your interface portion is 12:2. So what's going to happen now with Gigabit Ethernet 1/0 if I tell it to use EUI 64 for the global address? Let's examine this. Configure terminal, interface gigabit Ethernet 1/0. And now we're going to say IPv6 address. And what is our prefix in this case? It's 2001 DB8.1.12. So 2001 DB8:1:12. And then we have //64. And then we're going to say EUI 64. So just like we did on fast Ethernet 0/0. But watch what happens here. Watch what happens here. Look at this. Did it use the MAC address in this case? No. No. It said, well, we already have a link local address that you statically assign to this interface. As a result of that, I'm just going to go ahead and use that same interface identification that you put on the link local address for the global address. So if you want to statically set link local addresses on your devices and then set up global addresses using EUI 64, you could have them using the exact same interface identification as we see here. Interesting how the different how the different ways exist for this IPv6 address assignment. It is what it is. We have many different options, meaning that you have a lot of flexibility in your organizations for address assignment and addressing itself.